What are common mistakes in programming error diagnosis? Have you ever found yourself stuck trying to figure out why your code isn't working? You're not alone. Many programmers face similar challenges when diagnosing programming errors. Let's take a closer look at some common mistakes that can make this process even harder. First, it's essential to understand the different types of errors. Programmers often confuse syntax errors, logic errors, runtime errors, and compilation errors. Each type requires a unique approach to fix. For example, syntax errors are usually easy to spot because they are flagged by the compiler. On the other hand, logic errors can be trickier since the program runs but produces the wrong results. Next, overlooking logic errors is a frequent mistake. Logic errors occur when the code runs without crashing but does not deliver the intended output. Many assume that if the program runs, it must be correct, which leads to inadequate testing and validation. Always remember to test your code thoroughly to catch these subtle issues. Another common pitfall is inadequate testing and validation. Skipping tests or not covering various input scenarios can leave critical bugs hidden. Relying solely on manual inspection or limited tests is not enough. Comprehensive test cases are necessary to ensure your code works as expected. Ignoring compiler and runtime feedback is also a mistake. Compiler errors and runtime exceptions provide important clues for diagnosing problems. Some developers overlook or misinterpret these messages, slowing down the debugging process. Regularly compiling and running your code can help catch errors early. Many programmers do not fully utilize debugging tools. Tools like breakpoints, step execution, variable inspection, and logging can help you track the program's flow and state. Using these tools effectively can make it easier to identify where things go wrong. Not reviewing requirements or specifications can lead to misdiagnosis. If you do not understand what the program is supposed to do, you may misinterpret the errors. Collaborating with stakeholders to verify requirements before starting the debugging process is essential. Neglecting code reviews and peer feedback can also hinder your progress. Debugging alone can create tunnel vision. Involving peers in code reviews or pair debugging can help catch mistakes that you might miss. Fresh perspectives often identify issues more quickly. Overcomplicating the diagnosis process is another mistake. Jumping to complex solutions or rewriting large sections of code without isolating the problem can waste valuable time. Effective diagnosis involves breaking down the problem and testing incrementally. Failing to use assertions and automated tests can let errors slip through unnoticed. Assertions are checks in your code that verify assumptions during execution. Not using them means that bugs can persist, especially after changes are made. Finally, ignoring environment and external factors can mislead your diagnosis. Sometimes errors arise from configuration issues or differences in runtime environments. Always check these factors when errors are not reproducible locally. To improve your error diagnosis, regularly compile and run your code during development. Write comprehensive unit and integration tests to validate logic and catch regressions. Use integrated development environment debugging features to step through code and inspect variables. Review requirements carefully and confirm your understanding before diagnosing errors. Conduct peer code reviews and encourage collaborative debugging. Incorporate assertions and maintain a suite of automated tests to detect logic errors promptly. Lastly, always check environment settings and external dependencies when you encounter issues. By avoiding these common mistakes, you can improve your debugging efficiency and create more reliable software.